In this video, we're going to talk about the limit as x approaches pi of this rational function, and we're going to look at the limit as it approaches pi from both the positive and negative directions. When we look at this limit, we see that the x value is being squared, so that numerator is always going to be positive. So for the remainder of the video, we're really going to focus on the denominator, 1 plus cosine of x. So let's talk about the cosine function, and let's use the unit circle to help us. As you know, the unit circle has a radius of 1. That means these points associated with 0, pi over 2, 2 pi over 2, otherwise known as pi, can easily be written down as shown. Recall, the cosine value is going to apply to the x coordinate on the unit circle. So these are the cosine values. These are the values we're going to be looking at in this video. So let's go ahead and graph cosine of x using the unit circle, and the angle values will go on the x-axis, and on the y-axis is the actual cosine of x. So we are going to graph here in blue the function y equals cosine of x. So we're going to have an input of the x angle. The output is going to be these values here, and we're going to graph that on the y-axis. Okay, so when x is 0 degrees, that puts us right there. What is our cosine value? It's 1, because that's the distance 1. So the x value is literally going to be graphed on this y-axis. It's very confusing. Okay, let me repeat that. If the input value is 0 degrees on the x-axis, remember these are the angles. If the input is 0 degrees for this function, y equals cosine of x, if the input is 0, that's 0 on the x-axis, the output, which is y, is this x-coordinate 1. You almost can't keep a straight face as you say it. Okay, let's now divide this into 1/4 periods and proceed. So when we get to pi over 2, that's going to be this position on the unit circle. The input is pi over 2, so we're going to be right here on the x-axis of this graph, but the output is 0. That is the cosine of x. So when x is pi over 2, cosine of x is 0. And we're going to plot that right here, because that output is 0 on the y-axis. Now let's go to pi. When you're at pi, there's your input of pi as your angle. The cosine of x is -1. So that's down here. So this is -1 on the y-axis, and this is +1. Finally, at 3 pi over 2, we're going to be here. Our cosine value is going to be 0. That's the x-coordinate on the unit circle. The x-coordinate of the unit circle means that this cosine of x, when x is 3 pi over 2, is 0, and here you see it, y equals 0. When we go to 2 pi is a cosine value of 1, so we're going to be up here. So folks, this is your cosine graph. Let's now look at our graph, y equals cosine of x, and use our unit circle and evaluate our limit as x approaches pi from the negative side. So look what's going on here, folks. In this function is cosine of x. We have the graph in white, y equals cosine of x. So what are we going to be plugging in here into our limit? We're going to be plugging in y values. Here's our graph, y equals cosine of x. We're going to find out what the y values are, and we're going to plug that in for cosine of x. That's what this is about. Okay, here's all important pi. That's what we're looking at. The cosine of pi is -1. So at pi, cosine of pi is -1. Y equals -1. We plug in -1 here. How do I know y equals -1? Look at our graph right there. When x equals pi, y equals -1. Y equals cosine of x. We're going to take that -1 and put it right there. That white one has nothing to do with these ones. That's the one they gave us in our limit. 1 plus -1 is 0. You can't have 0 in the denominator. So that's why we're doing these limits. So look what happens, folks. As this x input goes towards pi, look what's happening to the y value. The y value is approaching -1. Over here, it's about -0.5. Here, it's about -0.9. Here, it's about -0.99999 right there. So if you have -0.999 and you add it to 1, you're going to have a positive, very, very small number like so. And whenever you have this very, very small number in the denominator, you're going to have this, x squared over, if you were to say this out loud, this is 1/10,000th. And if you have 1/10,000th in the denominator, that translates into 10,000. Very, very big. So as you approach pi, your entire limit's going to go to infinity. In terms of the numerator here, all you're doing is putting in pi for x and squaring it. So pi is 3.14, whatever 3.14 squared is, it's going to be 9 something. So it's really irrelevant. The numerator throughout this whole discussion is irrelevant. It's always positive and it's always going to be some number like 9 or 10. The action in this limit is in the denominator. Okay, now let's look at this limit coming from the other direction. And it turns out, folks, that nothing changes. Why is it that nothing changes? Because when you come from this direction, okay, we make that a positive. Look at your y values. Your y values are doing the same thing that they were doing when you were approaching from this side. The y values are progressing towards -0.9999. Right here, that y value is -0.9999. Not -1, not quite -1. When you take this -0.999 and you add it to that white one that they gave us, nothing to do with this one, the white one that they gave us, you get a very, very small positive number, and the entire limit goes to infinity. Positive infinity. Okay, let's now look at this limit using the unit circle. And we're going to do as x approaches pi from the negative, from the left. If you look at the graph, y equals cosine of x, when you're approaching pi from the negative, you are going from pi over 2 towards pi. So this is the portion of the unit circle we're going to be looking at to evaluate the limit coming from the left. Pi over 2 to pi, pi over 2 to pi. So let's just go ahead and do the opposite. That's the limit coming from the right. From the right on the graph, you could see 3 pi over 2 towards pi, 3 pi over 2 towards pi. Okay, let's now use the unit circle to figure out what the cosine of x is doing as we're approaching pi. This technique might be a little bit more intuitive because, folks, all we're looking for is the cosine of x here. We're not plotting a graph on an x and a y axis. We're just looking for the cosine of x. And what is the cosine of x? It's going to be the x coordinate on the unit circle. So let's say we're at this point right here. Okay, here's our angle. All right, that's our angle. That's our input angle. We don't even have to know what that is in this technique. But look at this point, okay? If I was to drop a perpendicular down here and a perpendicular down here, that would be the coordinates of that point. All right, so let's say we know that if you go all the way to the white point, you're at -1. So I'm going to say the cosine of this angle, again, I don't care what the angle is, but I'm going to say the cosine of that angle is going to be this x coordinate, which is going to be this distance. That's going to be -0.9 right there. Now, as the angle that we're looking at moves closer and closer to pi, let me give you a yellow angle now, here. And then I'm going to drop a perpendicular down. Again, I don't care what that angle is. I'm just looking at the trend. As you approach pi, look what happens to that x coordinate. Now it goes to -0.9999. Now, that's the cosine of the angle. That's what we plug in here. So if you start plugging in -0.9999, which is what's happening as this angle is coming towards pi, you're going to get a very, very small positive number, and that's going to blow up to positive infinity. Again, that numerator is always going to be positive in this problem. Okay. Lastly, let's look at this limit as x approaches pi from the positive direction. And I left one of these angles up to prove a point. If we're coming from the positive direction, all right, so we're talking about angles like this right here. So this would be our input angle. Folks, I don't care what that is. All I'm interested in is what's happening to the x coordinate. Okay, so here, if you have this angle, we're talking about this x coordinate. That's the cosine of x. If this is the angle, the cosine of that angle is going to be that x coordinate. So here it's going to be about -0.7. But as we move closer and closer to pi, look what happens to that x coordinate. It does the same thing that happened here. As we move this angle closer and closer and closer to pi, this x coordinate goes to -0.999. It's the same result. You're going to get positive infinity whether you're going this way or that way, because that x coordinate, which after all is the cosine of the angle, we don't care what the angle is, but the cosine of the angle is going to be the x coordinate of the point on the unit circle, which is going to be -0.999. And when you add that to 1, the one they gave us, not this one, the one they gave us, we're going to get a very, very small positive number, otherwise known as 0 plus. 0 plus puts us at 0.0001, and when that's in the denominator, everything blows up to positive infinity.